Hello, my name is Lorenzo Zal, and today I'll be going through Lab 1, the charge tape experiment. So, the main goal of this experiment was to observe the interaction between charge tape and determine how much excess charge is on one piece. And we accomplished this through the use of Coulomb's law and Newton's second law. So, as a result, we're able to calculate the charge on the tape, which was 1.119 times 10 to the negative coulombs, and was deficient of 7 times 10 to the 10th electrons. So, these are the two main physics ideas that we use, Coulomb's law and Newton's second law. And in this experiment, we pretty much determined the distance at which the two pieces of tape would repel each other. And since we have the K value and the weight of the tape, we were able to calculate the charge value, which is Q. And we set force electric equal to force of gravity because F net equal to 0. And we assumed that the charges were equal to each other for both pieces of tape. So this is in the experiment. We treated the upper tape as a system and the lower tape and the external forces such as gravity as the surroundings. So our initial conditions were that we were given two tape to charge and one base of tape to take away the electrons. And we did this by quickly ripping one piece of tape from the other to transfer electrons. And then we hung the upper tape on two external rulers and placed the lower tape underneath it and slowly raised it until it repelled the upper tape. And the lower tape did in fact repel the upper tape because they were both like positive charges. And we determined that the tape was positively charged because it was attracted by a negatively charged plastic pen in the previous experiment. So for our data, we calculated the mass by searching up the density of Scotch tape, and then we multiply the area. We had the K value, which is 1 over 4 epsilon naught. And then we measured the distance between the tapes at which they repelled, which is 0.02 meters. And we set the force of gravity equal to electric force in order to calculate the charge value, which is 1.119 times 10 to the negative 8 coulombs. And then we were also able to calculate the number of deficient electrons on the piece of tape by setting the charge equal to the number of electrons times the charge of a single electron. And we found that it was deficient of 7 times 10 to the 10th electrons. And then we also found the number of atoms on the surface of the tape by taking the area of the tape and dividing it by the atom diameter. And we're able to find the ratio of the electrons to atoms, which is 35 electrons to one atom. And this was the model that I made on GlowScript. So these are like the parameters we had, which is mass, the constants we had, which is the K value, and the gravitational acceleration, and the calculated distance at which the repelling occurred. And then these two lines here, they pretty much make the spheres for which represent the tapes. And then since there's we said they could be spheres because we treated them as point charges, which assumed that they would have like a equal distribution of electrons or deficiency of electrons on them. And then we also like created like a free body diagram for the upper tape. So we had the gravitational force going downwards that was equal and opposite to the electric force going upwards, and then it had an equal electric force because they had the lower tape was exerting an upward electric force onto the upper tape. And this is what it looks like. Obviously, you can see that the the downward gravitational force is equal to the upwards electric force. And then both the model and the data had consistent results with similar values for the charge of tape and the magnitude of the gravitation and electric force. And then the model was consistent with how I drew my free body diagram beforehand. However, we did make a few assumptions. We said that the tape had equal distributions of electron across the surface, and thus we could treat it as a point charge for easier calculations for Coulomb's law. And then we also assumed the dimension of the tape, which would also affect the mass and thus the electric force. But and some possible source of error was that the actual distribution of charge would have affected the repelling and attracting interaction between the objects. And there was probably some human error because when ripping the tape off or like setting the experiment up, our fingers would rip off onto the tape. And then there's also time between the charging and the testing of tape, which would also affect the charges. And if the electrons did have a positive charge and the protons had a negative charge, it wouldn't really change anything because the tapes would still repel since they both have the same charge as each other. And it's important to handle the charged tapes as little as possible because if the tape rubs onto your hands or other objects, it could potentially gain the electrons back that it lost. And as a result, in this lab, we were able to treat the objects as point charges to analyze how objects can quickly experience a transfer of electrons and their interactions with objects of like or different charges. And in addition, through Coulomb's and Newton's second law, we were able to calculate the electric force between objects.